This is a review of the second half of Chapter 8. Again, it's one of our last 100-point tests, last opportunities to bring up your grade. It's from sections 8.5 to 8.9. And on this review study guide, I explain what you're going to see on the test, how many types of questions, and I give a couple of examples. So up here, it says that there's going to be 3 factoring out the GCF. Factoring out the GCF is one of the most important and first types of factoring methods that we learned. So all you got to do is look at all your terms and pull out what's in common at the same time from every single term. So I have the 24, the 12, and the 18. What's in common with those numbers? And this is the way I start factoring out a GCF. I put parentheses, and then I start putting my GCF out here. So they're all even, so I could pull out a 2, but there's a greater value than 2. What could I pull out? 6, right? So let's put a 6 out here. But is there more than just the number 6? Is there something else in common like A's or B's? B's, right? Okay, now I have 9 B's in the first term. I have 5 B's in the second and 6 in the third. So what is the maximum amount of B's I could pull out from all 3 of them at once? The maximum amount of B's, 5. 5. Okay? Once again, if you're thinking I could pull out 9, yeah, you could pull out 9 B's from here, but you can't pull out 9 B's from here. There's only 5. You can't pull out 9 B's from here. There's only 6. So what's the maximum amount of B's you could pull out from all 3 of them at the same time? 5. That's the maximum that could come out. So 6b to the 5th is the GCF. And now we could figure, by doing reverse distributive property, what's left over on the inside. So 6b to the 5th times what will get us a 24ab to the 9th. What would that be? Somebody said 4ab to the 4th power, because when we multiply, we really add exponents. The second term, 6b to the 5th times what will get us a positive 12ab to the 5th? Positive 2a. That's it. No b's, right? Because b to the 5th, that's all we need. And for the last term, 6b to the 5th times what gets us a negative 18b to the 6th? Minus 3b to the, just b. Just b. You could put b to the 1 if you want, but it's just b. Because b to the 5th times b is b to the 6th. Ladies and gentlemen, that is an example of factoring out the GCF. There will be 3 of them out of the 20 on tomorrow's or on Friday's test. Okay? How do you know if you should continue? Good question. You always look at the inside and there's nothing else to do, right? On the inside, there's no perfect square terms on the front and the back. On the inside, there's no other things you could pull out. It's not even a quadratic trinomial where you could go a times c. It just doesn't work anymore. There's nothing else to do. So we know we're done right there. Here's another example of pulling out the GCF. We have a binomial here. What is the GCF right here? Let's pull out a 4 and also an r and also a t. If I do pull out a 4, an r, and a t from each term, what would I have left on the first term? 2 r to the 4th. And that's it. And then over here, minus 3 t to the 6th. Good job. And that's it. So as you can see, a couple of questions. It's just pulling out the GCF, and that's it. And of course, you're supposed to ask, could I do anything else on the inside? And no, you can't. They're not perfect square terms. There's no trinomial where you could do a times c. There's nothing else to do. Okay, so what else? There's going to be 4 factoring standard form quadratic trinomials where a value is 1. So factoring standard form quadratic trinomials where the a value is 1, those are easy. On these, you simply think what times what is a c value that if you combine together is the b value, and then you plug it into this format. So here we go. Because there's no number here in front, it's as easy as this. Set up your answer format, put the x, and then think what times what is c that if I combine together is b. So what times what is negative 48 that if I combine together is negative 13? Now, if you're confused or if you don't see the multiplication right off the top of your head, make a list. Start with the number 1, like negative 1 times 48. Or negative 2 times, on a calculator, go 48 divided by 2, that's 24. Negative 3 on a calculator, 48 divided by 3 is 16, so 3 times 16 is 48. Negative 4 on a calculator, that would be 12. Negative 5 doesn't work. Negative 6 times 8. And that's about it, right? Yeah. Now, which pair of numbers combines together to give us 13? Or actually, negative 13 is what we want. So when we start combining them, 48 and 1, that's 47, and that's not 47 in the middle. Right here, it's 22 if you add those, and the middle's not 22. Right here, when you add those, you get 13. And we have the right number, 13, but we want it to be a negative 13. So we have the right numbers, we just have the wrong signs. So I am going to rewrite that negative 3 as a positive 3, and I'm going to rewrite the 16 as a negative 16. And this is the right pair of numbers that we want. And those are the numbers that go right in here, positive 3, and right in there, minus 16. And that's how we factor. I purposely picked a number like 48 where we had a long list that actually took a little while. But most of the time it's super easy. You just think what times what is the last number that if you add together is a middle number. So like right here, what times what is 64 that if you add together is negative 20. Once again, because this is practice, I put some more challenging numbers. Let's make a list. 1 times 64. 2 times 32, 3 times, I believe, 18 on a calculator. If you go 64 divided by 3, you get 18. 4 times, on a calculator, 64 divided by 4, you get 16. And then I could keep going. 5, 6 doesn't work. 7, 8, 8 times 8. Anyway, which pair of numbers combines together to give me negative 20? If I add 1 and 64, I get 65. That's not negative 20. This is 34, not negative 20. This right here is 21, not negative 20. This right here is 20. So I have the right number, I just have the wrong signs. So what am I plugging into my answer? A negative 4 and a negative 16. And that's it. So there's going to be about 4 of those. I only gave you 2 examples, but there's going to be 4. And the numbers will be easier than 48 and 64. What else? There's going to be 2 factoring by grouping. So this is probably one of the least amount of questions that you're going to see on the test. But if you're going for the A, you're going to have to be able to do grouping. And on this paragraph, I explain how to do grouping. I'm just going to jump right into it. Step 1 is to make some space between the two groups. In other words, create 2 groups. Step 2 is to factor something out of the first group. What could I pull out of the first group? 3 and? So 3C is what we could pull out. If I do pull out a 3C, what's left? In other words, yeah, 3C times what is 3C squared? You said C, that's good. And then minus 2, perfect. Now let's factor something out of the second group. What could I pull out of the second group? Okay, you could pull out a 2, but notice if I pull out a 2, what will I have left on the inside? I'll have a negative C, right? But I don't want a negative C, I want a positive C. So let's pull out a negative 2 better. That way on the inside I'll have a positive C and also a negative 2 over here. That way we end up with the same identical binomial in the first group and in the second group. Now, the last step on factoring by grouping is to take a step back and factor out that common binomial in your first group and your second group. So that common binomial is C minus 2. So if I take this C minus 2 and this C minus 2 and pull them out here in the front, I'm going to have some parentheses left over. And what's left? This 3C's left and this minus 2's left. So you just bring them down, right? 3C right here and minus 2 right here. And ladies and gentlemen, that's your factored form. That was factoring by grouping. So there's going to be 2 of these. I'm only explaining one of them. When you write it on your answer, please write it with the correct size parentheses. That's it. Let's move on to the next type of question. There's going to be two questions on factoring quadratic trinomials where A is not 1. Okay, so these are more challenging questions, kind of like the grouping. Notice that the A value is not 1, so we have to do that multi-step process, and I explain it on the above paragraph. But right here we're going to do step 1, which is to multiply A times C, and what do I get? Wait a minute, time out. Even before doing this, you're supposed to try to pull out a GCF. But 12, 1, and 6, there is no GCF, so then we continue with these multi-step to be able to factor it. A times C is what? Negative 72. Remember, A is 12, C is negative 6, B is 1. So A times C is negative 72. Step 2 is to think of the multiples of negative 72. We're going to make a list. Negative 1 times 72, negative 2 times 36, negative 3 times, I don't know, let me do a calculator. 72 divided by 3, see if it works. It does, 24. So 3 times 24 also works. 72 divided by 4, will that work? 18. So negative 4 times 18. Negative 5 is not going to work. Negative 6. 72 divided by negative 6, that is 12. Negative 12, that is. I'm sorry, 12. So negative 6 times 12 is also negative 72. And that's about, 8. Negative 8 times 9 is also negative 72. That's about all the possible multiplication problems that give us negative 72. Now, which pair of numbers combines together to give us the middle value, B? Negative 8 times positive 9, right? That's the correct pair of numbers. If I add negative 8 and positive 9 together, I really do get a 1, right? I don't have to change any signs. So we move on to step 3. And of course, these steps are explained on the above paragraph. So step 3 is to plug it into your answer format and put your AX right here and your AX right here as the first part of each of the binomials. So when I say AX, I'm talking about this first term without the square. So I'm just going to put a what right here? A 12m. Okay, a 12m on both. Okay, now what do I do with these blank spots? What do I put in the blank spots? Yeah, the negative 8 and the 9 go right here. The negative 8 goes here, and the 9 goes here. Positive 9 goes right there. So let's plug that in. Negative 8 right there. Positive 9 right there. And if you read above, step 4 is to reduce your binomials. Now, this is the only time where you don't really show that you're pulling out a GCF. You just kind of in your head reduce. Like 12 and 8, you could reduce both by 4. And you're going to get your final binomial, which would be 3m minus 2. And the second binomial, you could reduce both by what? By 3. And you will get 4m plus 3. And ladies and gentlemen, we are done. We have factored the above quadratic trinomial. There's going to be 2 of those where you have to do all those multi-step process. So that's the end of the first page. Let's flip over the paper and work on side 2. So here's the back side of this practice or review for the test. And there's a couple of typos right here. Let's first start by changing this first typo. We definitely need an X right here. So that is 84X. Without that, it would be wrong. So we need an X right there. And then let's also go to the bottom of this page. And this 141, that was a typo. That should have been a 144. Okay, so 144. Okay, we need a 144 right there. So those are the 2 typos. I apologize. Of course, maybe you've already received a copy where I made these corrections. So anyway, let's jump right into it. There will be 5 questions on the test, the last 5 to be specific, where you have to solve equations using the zero product property. So on this one right here, it is already factored for you. All you have to do is recognize that you have something times something equals 0, so you could take these guys and split them and set them each equal to 0. And then you solve both equations by adding 8 Rewriting it, we have a 7x equals 8. Final step would be to divide by 7. So you have x equals 8 over 7. That is one answer. The other equation, we're going to get rid of that 21 by subtracting 21. And we will have a new equation that reads 7x equals negative 21. Final step would be to divide by 7. And x does equal negative 3. So those are your two answers for this problem. There's going to be one out of the 5 that are set up, ready to split and solve. Let's look at other ones. So right here on this one, we can't factor yet, and not only that, it's not set equal to 0. The whole purpose of factoring is to get multiplication. Like over here, we have multiplication, something times something equals 0. So because we have multiplication and it's equal to 0, we're able to split it and solve. If it wasn't equal to 0, we would not be able to split it and solve. So let's first make this one equal to 0 by subtracting 10x. What you do to one side, you do to the other side. Now, you can't really subtract 10x's from x squared or from numbers, so you can't really, you just need to rewrite it. 8x squared minus 10x minus 3 equals 0. Now, at this point, we have a quadratic trinomial, and the a value is 1, the b value is negative 10, the c value is negative 3. We are forced to factor using the multi-step process, right? Step 1 is to multiply a times c, and we will get negative 24. Step 2 is to think of the multiples of negative 24. And I made a list. Now we want to think of the multiples of negative 24 that combine together to give us the b value, negative 10, right? That's a b value. So if I add these, I get 23. That's not it. If I add these, I get 10. So I have the right number, I just have the wrong signs. Remember, I want a negative 10, not a positive 10. So let's just switch this to a positive 2 times a negative 12. And this is the correct pair of numbers I want in step 2. Now step 3, it depends which method you're using. If you wanted to use factoring by grouping, you would change your binomial, you would change the b value into these two terms, creating 4 terms that way you could factor by grouping. But the easier, quicker method is to do step 3 of plugging it into your answer format, your factored form format, and take this value, 8x squared, but write it without the square and put that 8x right here and put that 8x right there. So 8x in both first positions on the binomials. 8x, 8x. And then we take the pair of numbers from step 2, we take that 2 and put it right there. It is a positive 2. And then we take the negative 12 and put it right there. So I'm going to put minus 12. So it looks like that's our answer, but it's not, because if you actually distributed 8 times 8, that would give you 64, not 8. So what we do to remedy that problem is to reduce the binomials by the GCF of each. So I'm going to look at the first binomial. It's an 8 and a 2, and obviously both have a multiple of 2. So I kind of do this in my head. I'm not really factoring out a GCF. I'm just reducing, I'm dividing both values by 2, and I will get 4x plus 1. And on the other one, again, I could divide by 2, but let's go for the greatest value I could divide by, which would be 4. Okay, if we divide both by 4, I will have a 2x and a minus 3. So that's our binomial. Now let's not forget that this was an equation that was set equal to 0, so we need to bring that equal 0 down here. So what we've done is have it in factored form, and now we are able to split them and solve. Let me split them. And let me solve the left equation by subtracting 1 on both sides. I will have a 4x left over equals a negative 1. My final step would be to get rid of that multiplication of 4 by dividing both sides by 4. So my answer is x equals negative 1/4. The other one, let's get rid of that first minus 3 by doing the opposite, plus 3. So we're going to have 2x equals 3 left over. And then we need to get rid of that 2 in front of the x by dividing by 2. And we have x equals 3 over 2. Of course, you could write it as 1.5, but improper fractions, okay? Those are your two answers for this equation. Now that was obviously a lot of work. All right? How about this guy right here? Once again, you want it set equal to 0, so you're going to have to subtract the 6, and you're also going to have to add the 1m to be able to get rid of it. That's strange. I don't know why I put this 1 right here. You don't really even need the 1. You could just have it as minus m, so you'd go plus m. Whatever. Anyway, yeah, these guys would cancel out here and there, but what you do to one side, you must do to the other. So I'm going to add the 1m over here, and I'm also going to subtract 6 over here. But of course, I cannot add m squared plus m, or I can't even do m take away 6. They're all different terms, so all I could do is rewrite it. I can't really combine. So let me rewrite it. 12m squared plus 1m minus 6 equals 0. And now at this point, we have a quadratic trinomial. The a value is not 1, so unfortunately we have to do the multi-step process. Step 1, a times c equals negative 72. Okay. Remember, a is 12, b is 1, c is negative 6. So now we need to think of the multiples of negative 72. If you're not good at this, get a calculator. So negative 1 times 72, negative 2 times 36, negative 3 times 24, negative 4 times 18. So like, let's say you didn't know that 4 times 18 was 72. All you do on the calculator is get 72 divided by 4, and you'll see that it's 18. Okay. Negative 6 times 12. Negative 7 doesn't work. Negative 8 times 9. Those are all the possible multiplication problems that give us negative 72. So now we need to see which pair of numbers combines together to give us the b value, which happens to be positive 1. And if we look at the last pair of numbers, negative 8 plus 9, that is positive 1. And it has a correct sign and everything, so that's the pair of numbers I want. Anyhow, step 3 is to plug it into your factored form format. Okay, now what do we put in this first position of the binomials? We put this value over here without the square. So I want to take the 12m and put it here, and take the 12m and put it there. And then what do we do with these blank spots here? What numbers do we put here? We take the numbers from step 2 and we plug in the negative 8 right there and the positive 9 right there. So negative 8, positive 9. So at this point, we need to move on to step 4, which is to reduce each of the binomials. Because if you think it's already in factored form, it's incorrect, because 12n times 12m is not 12m squared, it's 144m squared. So you need to reduce the binomials. This first binomial we're going to reduce by 4. And when we reduce the first binomial by 4, we get 3m minus 2. And on the second binomial, we're going to reduce by 3. So we will get 4m plus 3. And now that's an equation that's in factored form. So because we have something times something equals 0, we could take these somethings and separate them, set them each equal to 0. And then we solve each of them. So if I add 2 here and add 2 over here, I'm going to have a new equation, 3m equals 2. Final step would be to divide by 3, divide by 3. So m equals 2/3. That is one answer. And on the other one, we subtract 3, subtract 3. We're going to have a new equation, 4m equals negative 3. Final step would be to divide by 4, divide by 4. M equals negative 3/4 is another answer. So let's move on. Down here, we have equations, and there's different types of solving these equations. Right here where you have a square, let's first think of it logically. What number squared gives you 9? What number squared gives you 9? Either 3 or negative 3. So you actually get two answers. So we don't want to think of this logically. We want to think of this algebraically. How would we solve an equation? We get x by itself. And since there's only one type of x, I want to get x by itself. So when I want to get rid of something, I do the opposite. The opposite of square, of the squared part, is a square root. So what I do to one side, I do to the other side. And when I apply a square root in an equation, the square cancels out, but the square root of 9 is 3, but I must put a plus minus in front of my answer. Because after all, from the beginning, we said that positive 3 squared is 9, and also negative 3 squared is 9. So it's both positive 3 and negative 3. That's why we write it as x equals plus or minus 3. Okay? So we actually get two answers for that equation. This one right here, we had to change this to a 144. Now, if you want to get rid of that 144, Maurice, what do? We have 144 times x squared. To get rid of a multiplication of 144, what do? The opposite of that, which is divide by 144. So that'll cancel out. What you do to one side, you do to the other side. Divide by 144. You will have x squared equals 121 over 144. So again, if you want to get rid of something, you do the opposite. The opposite of a square is a square root. See, you don't want this square right here. You want to get rid of it. So let's get rid of it by doing the opposite, square rooting. And what you do to one side, you do to the other side. So you do have x all by itself now. But since we took the square root in an equation, our answer is going to be plus minus. And let's not forget that we split the square root to the top and to the bottom. So the answer is actually x equals plus or minus 11 over 12. So that's actually two answers, positive 11/12 and negative 11/12. On this one, we want to get rid of the square. So how do we do that? We do the opposite of a square, which is a square root. What you do to one side, you do to the other side. So the square root and the square will eliminate themselves. They're going to disappear. So what do you have left? You have x minus 9 equals, since we're applying a square root, you need to put a plus or minus in front of your answer, and the square root of 144 is 12. So from here, we still need to get x by itself. We need to add 9 to both sides. Now that plus minus 12 is throwing me off, so I'm going to rewrite it. X equals positive 9 plus or minus 12. Now that really does provide you two answers. You could have the one situation, 9 plus 12, which equals 21. But you could also have the other situation, 9 minus 12, which equals negative 3. So you have two answers to these. And we solve these by applying a square root. Okay, so I don't want you guys to get confused and think that you could apply a square root all the time. You see, we apply a square root on this one because we got x by itself. And why did we decide to get x by itself? Because there's only one type of x. There's the x squared, and that's it. There's no other x's in the whole equation. If we go up here to the top part, this equation, I'm not going to apply a square root to get rid of the x squared. Why? Because I have two x's. So I cannot get x by itself because there's two types of x's. There's an x squared and there's an x. That is exactly the reason why I decided to move it to one side, get a quadratic trinomial, set it equal to 0, and factor this using the multi-step process. It's only when you have one type of x that you could apply a square root. Right here, there's only one type of x. It's just right there, x squared. Over here on this one, there's only one type of x. It's right there, it's x squared. On the last one, there's only one type of x. It's right there. So we get rid of the squares by applying square roots when there's only one type of x. But if you have two types of x's, or in this case m's, I have an m squared, I have an m, I can't think about getting m by itself because there's two types of m's. Now let's pretend that, that this one didn't exist. Let's pretend that the equation said 12m squared equals 6. Then yeah, for sure, I would get rid of the 12 by dividing by 12. I'd get m squared by itself. Then I would apply a square root because there's only one type of m. But in the original equation, there's two types of m's. There's the m squared and there's the m. That's why I'm not using square roots. Right here, that's why I move everything to one side and I factor using the multi-step process. Guys, tomorrow's the 100-point test. Maybe it's the last 100-point test in the year. You really need to try your best. Study this, do these questions over and over and over. Watch this video over and over. Good luck.